This video is sponsored by SerpApi. People spend years chasing the wrong role or worrying if they need a PhD to become a data scientist, machine learning engineer, or AI engineer. These roles are all AI related, but they are not the same. They are very much in demand right now with some of the highest salaries in tech. So in this video, we'll be talking about what each role actually does and their key differences, the salaries and market reality of these roles, the skills required for each one, and how to choose the one that fits you the best. And finally, we'll be talking about another job role that's becoming even more important for most businesses today. Okay, there's something you need to know. Every job has a downside or unfavorable aspect, so choosing the wrong role can lock you into doing work you don't actually enjoy and learning things you're not going to use long term. That's why understanding what each role does is so important in deciding which one would fit you best. You can think of these roles on a spectrum, from the most data/research focused to the most product/user focused. Data scientists fall on the data research end, which focuses on data analysis, finding data insights, and building machine learning model prototypes. In the middle, we have machine learning engineers who turn those models into reliable systems. On the other hand, AI engineers are the most product/user focused. They are at the core software engineers, but they focus more on integrating AI into existing applications. In terms of day-to-day workflow, for data scientists, you can think of them as data detectives who constantly ask the why question. They analyze data to uncover insights through exploratory data analysis, build machine learning models, and test hypotheses using A/B experiments, and this is mostly applicable for big tech companies only. And finally, they communicate findings through clear visualizations and reports. When I worked as a contract data scientist for a bank to develop for them a customer rating model or KYC model, know your customer, we analyzed a huge amount of customer data to find common patterns distinguishing high risk from low risk customers. And then we developed a machine learning model to help automatically classify those bank's customers using a popular machine learning algorithm called XGBoost. Another example, a friend of mine working at a large supermarket chain aggregates thousands of monthly customer reviews and complaints from their websites and use an LLM to help automatically categorize those customer reviews to find useful insights for management, which is super cool. One thing I want to note is that in recent years, LLMs have got a lot of attention, but as far as I know, most AI models used in enterprises today still rely on traditional machine learning. However, the data scientist role is evolving. As teams and organizations experiment with building things with Gen AI, many data scientists are starting to take on parts of the AI engineer's job. We'll talk more about that role in a moment. Just keep in mind that in reality, the line between these roles can be quite blurred. But to do data analysis, you need data, sometimes lots of data, and sometimes even real-time data from the internet. In reality though, getting the data you need is often the most challenging part. So I'd like to give a quick shout out to SerpApi, who has kindly sponsored part of this video. SerpApi provides a web search API which helps your AI applications look up real-time information using search results from Google and other major search engines. It basically turns raw web data into structured, reliable data you can use, which is ideal for AI agents, automation systems, research pipelines, and enterprise applications. For example, if you're building an AI application to analyze daily financial news or an AI agent that researches product market, you need access to fresh and real-time information on the internet. And SerpApi provides tons of easy-to-use API endpoints to help you do exactly that. You can access the API via simple fetch requests, and SerpApi also has simple integration code for the most popular programming languages, including Python, JavaScript, Ruby, and even Google Sheets. If this sounds interesting to try out, you can sign up on their website to get started for free. Alright, back to the video. While data scientists experiment with models, someone else makes sure those models actually work in the real world. And that's the job of a machine learning engineer. Machine learning engineers train, deploy, and monitor machine learning systems in production. They optimize optimize model performance, manage data pipelines, and ensure models run reliably at scale. Machine learning engineers are very high in demand, and they are among some of the most sought-after talents in tech, and there's no sign of this changing anytime soon. Some reports predict the machine learning market to grow at a steady pace of 40% per year between 2025 and 2029. Also, among the three roles, machine learning engineer has the most brutal competition. From my observations, entry requirements for these roles are quite high in terms of academic background. So yes, if you have PhD in math or computer science, that would be a major advantage. A typical day for a machine learning engineer involves working with model training pipeline, testing deployed models, monitoring how they perform in production, evaluating results, and updating them as new data comes in. And lastly, we have AI engineer role. And AI engineering is really booming right now. According to LinkedIn's Jobs on the Rise 2026 data, AI engineer is the fastest growing job role in the US. AI engineers focus on building AI-powered products and features that users directly interact with. AI engineers don't build the AI models from scratch, but rather they work with pre-trained models like LLMs, can be any other AI models and not necessarily LLMs, and design systems around them. They build things like RAG or retrieval augmented generation pipelines, AI agents, and tool-connected workflows using an MCP server to solve real business problems. For example, an AI engineer may build an internal AI system that helps employees quickly cross-reference information from internal policies and reports. Other cool AI engineering projects may include AI-powered chatbots, building a chatbot that retrieves and answers questions from your documents in a specific domain, semi-autonomous AI agent, create an agent that can book appointments or complete multi-step tasks independently. Tool-connected workflow system, build an AI that connects to external APIs, for example, Stripe, Google Calendar, Notion, using MCP to automate tasks. Custom LLM integration, fine-tune or prompt engineer a pre-trained model for specific business needs, for example, legal analysis or medical coding, etc. And finally, multimodal AI application, develop an app that processes both text and images, for example, analyze receipts, extract data from screenshots, describe photos, etc. In terms of compensations, machine learning engineers and AI engineers generally earn more than data scientists due to their proximity to production systems and products. According to Indeed Jobs, data scientists typically earn between $80,000 and $208,000 per year in the US. Machine learning engineers often earn 15 to 40% more, and AI engineers fall somewhere in between depending on the company and product maturity. But before you start daydreaming about buying a yacht with your first paycheck, let's talk about the skills required for each role so you know what to focus on learning. To help you visualize how the skills for these three roles differ and overlap, let me show you this Venn diagram. Let's start with data scientists. At the foundation, Python and SQL are non-negotiable. Python is the primary tool for data analysis and modeling, while SQL is essential for pulling and working with data from databases. R programming still shows up in some roles, but today it's mostly optional unless you're doing heavy statistical research or working in academia. Beyond programming, statistics is the real backbone of data science. This includes hypothesis testing, regression analysis, probability, and experiment design. Data scientists also need solid machine learning fundamentals. There's no need to know a lot of math, but you need to understand applied machine learning well enough to build and evaluate predictive models using libraries like scikit-learn. Then there's data visualization and storytelling, which I love so much, and tools like Tableau, Power BI, or Python visualization libraries can help turn raw numbers into insights people can actually understand. In reality though, what truly separates great data scientists from average ones is the communication skills. If you can't explain well the insights and what the data means and why it matters to non-technical stakeholders, the analysis doesn't drive impact. Regarding the skill stack of machine learning engineers, their core language is also Python, but at a very different level. This isn't just scripting on Jupyter notebooks, but this is production-grade Python. And that means clean code, object-oriented design, testing and writing systems other engineers can maintain. On the modeling side, machine learning engineers work with frameworks like PyTorch and TensorFlow. PyTorch is often preferred in research environments, while TensorFlow is common in large-scale production systems. A machine learning engineer is expected to know infrastructure and deployment, and you're expected to know tools like Docker for containerization, Kubernetes for orchestration, and at least one major cloud platform like AWS, GCP, or Azure. Machine learning engineers also work heavily with data and pipeline tools like Spark and Airflow to handle large-scale data processing and model training. So what makes a great machine learning engineer is systems thinking. So you're not just training models, you're also designing end-to-end systems, monitoring performance, and keeping everything running when things inevitably change or break at some point. For AI engineers, your core skill is working with large language models like GPT-4, GPT-5, Claude, Gemini, or open source models. But you don't actually understand these models from a foundational math perspective. You just need to understand them functionally. And this includes prompt engineering, fine-tuning when necessary, evaluating outputs, and managing latency and API costs. Oftentimes, you also need to do data engineering as well to get the right data in the right place to invoke these models effectively. You're also expected to know how to build a RAG system, so retrieval augmented generation, so models can ground their responses in real external data instead of just hallucinating. You also know how to design AI agents, so systems that can use tools, make decisions, and execute multi-step tasks autonomously using pre-trained models. And another emerging skill is building and using MCP, or Model Context Protocol, which is becoming a standard way to connect AI systems to external tools, APIs, and data sources in a structured way. And finally, deployment and reliability matter. So AI engineers need to know how to ship AI features safely to production, monitor them, and iterate quickly. A good AI engineer must have good product thinking, and you're also essentially a good software engineer. Now, no matter which role you choose, to set yourself apart in today's market, you need to know how to use AI to work effectively. For example, leveraging AI coding tools and automating tedious parts in your workflow to save time. And this is an overarching set of skills that's needed for almost any knowledge work jobs today. So now, knowing all this, how do you decide what role to go for? My take on this is, if you love analyzing data, finding patterns, running experiments, and telling stories with insights and influencing business decisions, then data science could just be a path for you. On the other hand, if you enjoy building robust systems, optimizing models, and solving engineering challenges to make AI work reliably in production, then machine learning engineer might be the right fit. Finally, if you're excited about creating AI-powered products, building applications with LLMs, RAG systems, and AI agents, and delivering features that actual users interact with, then you should definitely consider AI engineering. And the good thing is that for this role, you most likely don't need a PhD. Now that you have a sense of which role fits you, the next step is to learn the skills and start building your portfolio. The key is consistent practice and learning by doing rather than just reading about concepts. For data science, I have lots of portfolio project tutorials and ideas shared on my channel. You can aim to build a portfolio with 2 to 3 projects that showcase data cleaning and exploration, statistical analysis and hypothesis testing, machine learning model building and evaluation, clear visualizations and insights communication, and optionally, A/B testing or experimental design. For machine learning engineer, you may start learning how to containerize and deploy a machine learning model in production. I have some videos on this as well. And for AI engineer, I also have a few portfolio projects, from building RAG systems to building small AI agents, and you can use them to inspire your own projects. And if you want a structured way to fast-track your learning, check out my Python for AI project course. And this course is designed to take you from Python basics to machine learning fundamentals all the way to building full AI projects. And in the beginning of the video, I hinted another data job role that is also becoming very, very important, and that is because of a dirty secret. Most companies nowadays don't actually trust the data. The data is a mess. As much as companies want to build AI applications and models internally, if the data is messy and unusable, there is not much they can do. So data engineers are the people people who make data usable before anyone gets to analyze or build any applications around it. So if you have the data engineering skills to help them fix this problem, you're golden. And today, this is also a very viable career path. Now, at the end of the day, data scientist, machine learning engineer, and AI engineer are all great paths. They just optimize for different kinds of work. Whichever you choose, the fastest way to learn and to get hired is to build proof. 2 to 3 portfolio projects that demonstrate real skills, clear communication, and the ability to deliver something end-to-end. For example, in this video, I show you step-by-step how to build an application for extracting invoice information and how to deploy it. Feel free to check it out. Thanks for watching. Bye-bye.